Okay, so today I'm going to walk you through how I image one of my 3D spheroids on the Opera Phoenix. And I have this screen here, and hopefully everyone can see my mouse. But basically when you start, I go to Settings, and then Assay Layout Editor. And I'm going to create, this is for my specific experiment, but you want to create a plate map because this will go through with all of your analysis, and this, whatever you label here, will stay with the experiment. Now you can go back and add this at the end, but ideally you remember to add it at the beginning and try to just keep everything organized. So let me just finish doing this. Okay, so I have my compound, then I have my concentration. And these can be copied in from Excel. So if you have a lot of samples, you can copy and paste this information from Excel. I'm going to enter my cell type. And then I'm going to hit save. And I'm just going to label it with today's date. And then you can label it whatever you want here. And then you can hit OK and then hit OK. Do you want to load to the assay layout on the setup screen? Yes. And then you want to grab this, and then you can see over here that this is your plate assay. And one more thing, and when you're in here, and you have your samples that are live, you can go here to turn the temperature or the CO2 on. So you want to do that right away as well. So next we're going to go to, you're going to want to be on the setup tab, and you're going to start at the top. So there's a whole bunch of plates that are preloaded in. And any plate that's not preloaded in, I can help you set up. But today I've got a 24 well Eppendorf plate in here. These two, if you right click help, it will help you pick which one you want. I usually pick the default. We have 5, 10, 20x air, and 20, 40, and 63x water objectives that are available on this machine. For my pre-scan, I'm going to start with a 5x air. I'm going to do confocal. I'm going to keep my binning at the default, which is 2. Now I'm going to come down here and I'm going to add my channels. So for my spheroids are labeled with a Hoechst stain that's going to label the nuclei. I also have in here on this plate GFP and RFP labeled cells, but I'm going to use the Hoechst because it's going to be all of my cells, and I want to see my whole spheroid. So I'm just going to select Hoechst. And then you can leave these as the default to start with. Next, you're going to go to the layout selection, where the number of wells is going to come from on the right-hand side here, how many you select here. So number of wells is up here, so I selected 16. That changes to 16 here. To start with, to test this out, I only select 1. And same thing down here, I only select 1. When you are doing more than one field, you want to have it overlap. So I usually set it to whatever makes sense for what I'm looking for. So for here, I want to have a good part of my well imaged. The other thing too is that, so, you know, this is like partial wells here. If you right click and select or unselect field centered, so now I can select a bigger part of my well and image the same number, or like more of it than I can if this was centered. So here I can only get this many wells. If I undo check that, then I can get more. So I typically start with like -20. I do, hold on. So, and then I select, to start with, the very first time, I select how many microns I need. I just want to find my spheroid, the general spheroid. So I kind of do where I think my spheroid will be, and I start there. So now I can say, okay, I think it might be between this plane and this plane, somewhere along there. So I'm gonna come up here and do test. So select a single well. Sometimes it likes everything that's selected to be like selected with orange. So now you can see by the rotating green arrows that the machine is working. So every time you hit test or anything to run, you have to go to test images, this other tab, and when it turns blue, that means that it's done. So you need to select this orange, make this orange, and then now you can go through your Z slices and you can see where your spheroids are. So for this, I want to have generally where the top, I want to be above and I want to be slightly below where my spheroids are. So if I come down to the bottom, I can see that these are out of focus. So that means I'm below my spheroid. But getting up to this 0, you know, I might start with 0. And then as I go through, I can tell that I'm not all the way through my spheroid. So now I'm going to come over here and I'm going to select. So I said, okay, -10 is where they start roughly. And I'm just going to increase this to 30. And then I'm going to hit test again. Then I go over to the second tab on the right here, test images. Click on this well, click on this well, and then I'm going to click on the bottom Z stack. So now I'm going to go up, and I can see where my spheroids are. So I would say, just to be on the safe side, that this is definitely way out of focus. Maybe I'll stop at 380 microns. So I can take off 3 from here. So now I'm going to save this setup. 2020 814, and you can call this, if you're going to change it for every experiment, or if you're going to save, you know, this is just for today, but I'm going to have what the experiment is, and then I'm going to put pre-scan. So the next thing I want to do is I want to select another well and just verify that all of my spheroids are going to be within this range. I'm not cutting any of them off. So I'm going to just hit test, and it's going to image this other well. Let me go to my test images, click make everything orange. And one thing too that you can look at is intensity. So if you right click on your mouse and then select show intensity, as I go through the spheroids, you're going to see how the intensity changes. So here for this specific spheroid, you can see that it's pretty small and I get out of it pretty quickly. So I'm going to go back to my define layout tab, and I'm going to guess my spheroids are closer to down here. So I'm going to select same well, different area, and do another test. I'm going to go to my test images. So again, I'm just going to right click, show intensity, and select that just so you can see how the intensity changes. The overall intensity doesn't matter too much for the pre-scan, but you want to make sure that there's enough difference between the background and the foreground. So here, the background is kind of in the low 100s, and my spheroids are, above 1,000. So and the difference between the two cell types, they're both pretty different than the low 100s. So that's fine. But as you can see, my Z-stack isn't high enough. So I'm going to come back over here on the left to my Z-stack, and I'm going to say, okay, I want to make sure I'm getting all of them. So let's go to 500 microns, and I'm just going to try that, hit test again. Again, go back to test image, select on this, and go to the bottom of my Z-stack. So as you can see here, for this well, the highest one is at 455, and then they go out of focus. So I'm going to leave a couple on the top. The bottom, I kind of know that this is like the bottom of the plate, so they shouldn't be any higher than that. I'm going to keep this at 500 just to make sure that I have all of my spheroids. And if you think that your spheroids are any higher, you can check another well. I typically do 2 or 3 checks just to make sure. So now, once we have a test image, the way of pre-scan, I use the pre-scan to find where my spheroid is so that I can then go back and on the 20x objective, and I can image just where my spheroid is. So if we come over, so basically you're going to want to attach an online job, which is just an analysis sequence. So to make the analysis sequence, you're going to go over to Image Analysis tab on the top, and you're going to go to New. Well, I'll walk you through this one. This is the one that I already have saved. But basically, you're just going to select, you want 3D analysis. So you need to select the entire Z-stack in order to see what you have. So now you can see that you can see where the spheroids are, and you can see where they are in the Z direction as well. The other way to look at it is in the 3D view. So you can kind of see where they are. You can manipulate this. So if you select this little triangle next to the channel, you can, kind of play with this to try to get rid of some of the background so that you see where your spheroid is. Now this doesn't change the intensity, but this just changes what you're looking at. And there's different different things. If you right click help, this will walk you through what everything else over here means. I'm gonna leave it on this view because this is what I find the best. When I put back on auto contrast, again, if you right click intensity, you can see that the intensity, the background intensity is around 150. So if you want to bump this up to like 150, just move some of that background to make it a little bit crisper, you can. So now I'm in 3D. So now I'm going to go to the bottom right. And the way that I found these is by doing find image region. There's also, you can find the texture region is another way. Or you could do find nuclei, whatever you find that works best for your sample and most accurately finds your spheroids. So I have this already preloaded, but you can see that I'm generally getting my spheroids. They're identifying where the nuclei are pretty accurately. It doesn't need to be perfect, just pretty accurate. So the threshold, if you right click here, you can find what all of these mean. The help is actually really helpful in this program. So you can kind of see the different, there's local, absolute, and whole image region. So I use local, so this, kind of has, to find blobs of high intensity. That's kind of what I'm looking for. It's just my blobs, which are my cells. And this kind of walks you through everything. So I'm not going to go through everything here, what it all means, but this manual is really helpful, and this will help you set this up. So you can see, like here, I have it at 1, but if you change the threshold to 5, then the cutoff is too high and you're not really finding anything. So you can kind of like play with this. Like I bet if I do like 3, that will change it. It'll identify it like a smaller area or nothing. So I'm going to keep that at 1. Ideally, the less settings you have to play with, the better. One of the things too is that I have this at 500,000. So if you have this lower, for here, for example, you're going to have your spheroid, but then you're going to have this little blob next to it. So I don't want little blobs. I only want big blobs. So if you right click zoom to fit, I'm using my mouse to zoom in, but you can also right click and zoom this way as well. I'll go back to this. So you can see like all of these different colors are different spheroids. So I don't want any of those. So I threshold out what I want. And then you hit, whenever you make any changes, you want to see it show up on here, you just hit apply. So what you can see down here on the bottom is that you can see that if you right click highlight objects, this will show you for the individual object. You can organize by size, so you can have smallest to largest. So if I had this at 0, I could say, okay, so these ones, when you click on it, it's going to bring you, these are all like not what I want, or you can go from the opposite direction. You can say, okay, that's a spheroid. So where does it goes from spheroids to like not full spheroids? These are partial spheroids on the edges. So you can say, okay, well, this one's getting closer. So you can, make a cutoff based on what is detected and what you want. So I had picked that, so I'm just going to keep it at that. So now the way that this works is, so you've gone through, you've selected your channel, and you've gone through and you've found your blobs. The output image is image region. You can relabel this whatever you want. The next thing I do is calculate morphology. So I just want you know, your population that you've already created, and this population is going to call from anything that above that building block. So I just want to report volume. So this is, I wanted to get spheroids that were greater than 30,000, but also less than a number. And again, this goes back to this tab down here, where you can specifically look at your blobs and set cutoffs as you wish. If you're detecting something, you know, like if there's debris in there and it's really like, these are kind of blobby, or circular, but say you wanted to, you had things that were lines, and you know, mine are pretty close for sphericity, but if you had like a piece of debris in here that was a line, the sphericity number, for example, would be completely different. So you can set a cutoff in your select population tab. And again, right click, help will tell you what all of these mean. So you can use the different features to select select your spheroids that you want. So here on this tab, green is what is good and red is what is not. One other cutoff that you can have is select population in your, so now I call these remove small spheroid up here. So now I'm going to call that population. And I want to do a common filter. So if it's touching any of the image faces, side faces, top or bottom faces, for what I'm looking for, I'm kind of only looking for the middle Z. Depending on what you're looking for, you can use these cutoffs. So I'm going to keep it. I don't want any of the ones that are touching the edge. So, because these are kind of at different heights. So here, down here, it shows these are touching the edge. These are only partial spheroids. So now it's not going to image any of these partial spheroids. And that would matter because, you know, the volume could cut them off too because they're so small, because they're small part of them is on this one. But the next thing I'm doing my population, remove small spheroids selected. That's just what this building block above is. So if I had used this image region, it's going to go back to this one. Remove small spheroids, it's going to go back here. This is why these labels are important as you make bigger analysis sequences. But so here I'm going to do this most recent one, the region. I only have the one region. So now I want to know the Z position. So I want to know the lowest, middle, and highest plane. So for example, I'm going to show this object. So the lowest plane that this is detected down here is at 254 microns, and then the middle is going to be 373, and then the top is going to be 493. And it shows the volume here as well. So if you're getting something small here, you can still go back and tweak your protocol. And so again, you know, there's other ways of doing this. So if you just right click, you can see the other ways of finding and accurately identifying what you're looking for. So now the key here is to determine the well layout. So now again, I'm going to go back to my most recent one. It's only one image. So individual objects versus multiple objects, that has to do with yeah, let's see. Let's go to the help so I can explain this correctly. So this is to put as many objects in a single field as possible. The number of fields in the rescan is reduced. If you select a method Z, only one Z position will be calculated for all objects. So it's the mean. So you have one at the top and one at the bottom. It's going to start in the middle of the two. if you want to do individual objects, so if you have one down here and one up here in the Z, it would calculate them, they would image them separately. So I select mine generally by the middle, just in case I have some touching the top or the bottom. I choose not to exclude those because typically they're going to be, I don't know. I just find it easier to do the middle for my stuff. But again, you can go and select and make sure that the spheroids. So the other thing here is, so I select individual objects because I only want one object per square, ideally. Max number of fields. So this is going to depend on how many spheroids you want imaged, and one field is just this one box. So when I have this whole thing, when I go back and do this for real, I'm going to have this whole, you know, I'm going to have 4 by 4, so 16 fields image. So if there was spheroids in all of these, it'd be 16 times 5 that were imaged. My gel is probably only saying like 6 of them. So if I say 6 times 5, you know, I'll get 30 spheroids roughly. Object margin is how far apart you want them spaced if 2 objects are next to each other. And then field overlap is if there's another spheroid right here, how much overlap do you want in the 2 fields of view if they're right next to each other. And then I'm going to do mine based on the middle. So now, and this objective is really important because if I switch it to, for example, a 40x objective, it's going to make my imaging box smaller. So why that's like that, I'm not exactly sure, but let's look at one of the other ones. So this one is saying that this is bigger than one field of view. So this is where the overlap comes in and the object margin. So this is saying you need 4 boxes in order to image this object. But I'm imaging on 20x, so I can see that it accurately shows these in the middle. My object's in the middle, and in the Z plane, it's also shown in the middle. So then here you just go to define results, and you don't actually have to have anything here checked or anything for the pre-scan. In a normal analysis, you would want to have things, would want to export any data. If you wanted to know in the 5x how big your objects were, for example, you know, you could go here and you can have all of this information selected. But for this, I don't need any of this information. So then you're going to hit save. I save this as, you know, my pre-scan 24 well plate, and then it's 20x. So I typically make my pre-scans based on, you know, so this is, it's going to 3D spheroid. It's going to be, the pre-scan is detecting hoax. It's in a 24 well plate, and I want to rescan at 20x. So that's just what I save mine at, and I kind of use them as building blocks for my different projects. So now, once I'm happy with that, I can go over back to setup tab. I want to add in my analysis here. So this is the 3D pre-scan 24 well 20x that I was just showing you. So I'm going to hit OK. So now I'm going to go back over here on the right to define layout. I'm going to pick a totally different well. One, to just, you know, make sure I don't photo bleach my sample, but also just to make sure that everything looks good. So when I come over here, I want to make sure that in my test that I have all of this selected because I want it to look like it will when it runs for real. So I wanted my analysis to run for this test as well. So I'm going to go back to test. So again, I want to go to my test image tab on the right, make this orange, make one slice orange. And then I can, as it's imaging, I can look at, make sure, just check that I have spheroids here, check that they are fully in my detected area. So now, you know, I'm happy with my intensities. Just double check them. I'm happy with my intensity. I'm happy that I am within the bounds of my whole spheroid. So I'm going to check my analysis. So I'm going to go to image analysis. I'm going to select my entire Z stack on the right here. So now this is going to bring me back to this tab. So now I'm going to go through each one and just double check that everything looks good. I'm going to select what my spheroids are, make sure they detected accurately, go through, it's going to detect my volume. They're within the range that everybody is green here. Oh, I forgot to save it with my, so let me just add back in here. So again, I want to go to my remove small spheroids, which was the most recent one. Remove objects that are touching the sides. Now this is called remove small spheroids selected. So I'm just going to follow that up here so to make sure that it's selecting the right ones. And then the most important one is, okay, so lowest, middle, highest. Individual objects, I'm going to do 20x objective. I want to do 5 fields. So down here on the bottom, so this is red is showing me there's an error. I can look at my messages and I can say population removed, small spheroids does not contain any suitable Z position property. So you can click on the arrow on the bottom to get more information. And some, you know, this will bring you to the help manual as well. So let's go back here for my spheroids. Let's see, it's showing me it's calculating these. Let's make sure I have the correct, okay, selected. There we go. So I had my population incorrect. So here we go. So now I'm going to use the bottom one and then Z position of the middle. So now I'm going to check that this is in the middle for that one. It's in the middle for this one. I already checked and it's roughly in the middle for this one. And if you weren't happy with where this is, you can start at the top and go through and correct that. So now I'm going to just click on define results. I'm going to hit save, which is what I guess I didn't do last time, so I'm just going to save this. Okay, the analysis sequence, blah, 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 was modified till the current be loaded to this pre-scan update to this new version. So I'm going to go, yes, please update. When I come back to setup, if I change the name of it, the new name would be here, but this has the analysis sequence I just saved attached here. So now I want to just resave this pre-scan. And then if you want, you can go and check another well or not. I'm going to pick another well just to make sure. I'm just going to quickly check. So I just need to make it orange, hit test. Now I'm just making sure when I go to the next well that I have my spheroids here. So then next I'm going to go to the rescan. So the pre-scan was used to find my spheroids, and now the rescan is going to scan my spheroids based on the output from the analysis sequence that I created. So it's going to find where the middle slice is, at what height it's at, and then it's going to image based on that analysis sequence. So if I go to my test image, you can go here. I pretty much just want to know here, my height still looks good, and there are spheroids here. So I'm just going to make sure that this is saved one more time. So now I'm going to go back to new, and I'm going to set up my pre-scan. So I'm going to select my plate, and it 24 well Eppendorf. I'm going to keep this as the default. So now I want to image in the 20x water, and I want to do confocal. So as I mentioned before, I have 3 channels set up. So I want to image my host, and then I also have 2 others. So I have Cell Tracker Green, and there's a bunch of these already preloaded in here. So I have Cell Tracker Green and I have Cell Tracker Red. They're not here. They could be under this other PKI, which is also, or you can make your own. Some people have made their own. So here, the intensity, I leave this as the default to start with, but the intensity here is going to matter a lot more than it does in the pre-scan. So now, when I go here, so overlap doesn't matter so much because it's going to be whatever you selected in your analysis sequence. But so when you're doing your, so your Z height of 0 is going to be the middle slice, or if you select the lowest height in your analysis sequence, it's going to be 0 is going to be at the bottom of your spheroid. So you just want to keep that in mind when you are selecting this. So I am going to start 130 microns below my center height. I'm going to do 56 planes. We'll try that at 5 microns. So this basically, you can look on the right over here, it goes from negative 130 microns, 5 microns, up to 140 microns. So I'm basically saying that my spheroid, I think, is generally less than 270 microns total. And again, I'm not going to do a test here because otherwise it will start at 130 microns below 0 on, instead of starting where I already detected my spheroids. So I set up, basically here, I want to set up my channel and I want to set up my Z height. So now I'm going to save this. So here I'm going to select the same well that I did in my pre-scan when I most recently saved it. And then here, it doesn't really matter. You can select everything, nothing. It's going to be based on your analysis sequence data. So now I'm going to call this my rescan. So I'm going to save it. So now I'm going to do a test, and with the pre-scan and the rescan, the way to do that is by going to run experiment, which is going to save the data. Whereas when you're over here in setup and you're hitting this test button, it's not actually saving anything. But the only way to do the pre-scan and the rescan together is go to run experiment. So I'm going to go to Preci-Scan is the feature I want. So I'm going to have my pre-scan here. So I'm just going to pull up, and you can see the date, the time. This is what I just did. And then I'm going to put my rescan here. And if these are not the same plate, not the same well, not the same setup, this will show up red. You're going to have to come back over here, open the pre-scan or the rescan, and then edit it so that they match. Your assay layout for the test doesn't matter, but when you actually run this for real, you're going to want to select your assay layout. So I call these tests just so that I can easily delete the data later, because I don't actually want to save this long term. So while you're in this run experiment tab on the top, you're going to see that your assay layout is here. And if you can make these different features colors so that they show up, and you can highlight the different colors here. But this turned blue, so this is done. So this is showing that my pre-scan detected 4 or 5 different spheroids. So now, once one of these turns blue, it will show you where it's at. But as you can see, one it detected as the middle is different for all of these spheroids. So that could be because the spheroids are at different height. What I have imaged here is I have a 12-well Avros mold that I have cut the edges off and I have flipped over. So some of my spheroids have not settled down to the bottom, so some of them are going to be higher up, which is okay because they're going to be detected. But this just shows you that the pre-scan detects the height. So whatever height those spheroids are at is what this is going to be. So now, because this is the first time I use the 20x objective, it's going to take a couple more minutes just to do whatever the machine does while every time you switch the objective. So as soon as one of these boxes turns blue, that means it's finished imaging. So here you can see that it's detecting my spheroids. So I'm going to come roughly in the middle. So basically you can see, you can come over here on the right to, this is going to show you what you're actually looking at. So I'm going to start and go channel by channel. I'm going to right click, I'm going to do show intensity, and I'm going to just go through my, click here. Ideally, I want my intensities at all the way through to be at least 2,000 or 3,000. So I'm going to say that this one needs to be bumped. This one needs to be increased. So we need to increase the green. The other thing that you want to look at while you're going through is see where your how big your spheroid is. So you can say, okay, you know, here's kind of like the last one. So you want to make sure that you go down, but you know, I could trim off some on the bottom and then same at the top. You know, my spheroid kind of ends here. So I would, you know, I could maybe trim some off. I would look at a few different spheroids just to double check. So now I'm going to go to my next channel, which is my red channel. Again, go roughly. You can go down each slice. You can see that this is absolute garbage and the intensity is way too low. So this needs to be increased a lot. And then next, let's go to our hoax channel. And this one looks pretty nice. My hoax staining is generally more intense. So you can see that the background intensity is, you know, between 100 and 200. My nuclei are, pause because it finished imaging all of these. So now it's saving everything. Okay, there we go. So now you can see that these are nice. These are good. I want them to be at least 2,000-3,000. So now I'm going to just go through and look a little bit higher. These are still above 2,000. So the other thing that you can do, the other thing to keep in mind too is, let's go kind of towards the middle here. So this is in highlight view. There's enhanced and there's standard. And as you can see here, this is the min, the gamma, and the max. This is just what you see. So the different settings are kind of like preset settings, but you can change any of these. So if you're like, you know, my nuclei, because it's 3D, aren't perfect, and I'm doing 5-micron slices. So I do get some background from above and below. You can either, you know, you can change everything, you know, so that you get less background. You can reduce your size or, you know, whatever. So we have a lot of changes to make. So now what I'm gonna do is, and I would look at, so this image 5 nuclei. So, you know, you can go through and look at all of them. So you want to just make sure that your whole sphere is here. You can kind of write down where it starts and where it ends so that you know roughly how big it is, so that you could say, I don't really need to image this and I don't really need to image this. You can reduce your height. So now if we go back to setup, and we're going to load our rescan is what we need to edit. So here, basically there's 2 settings because I said the hoax looked good. So the hoax is at 100 milliseconds, 50% laser power. That looks good. The height for 3D doesn't matter. It matters for 2D though. So for my green, I'm just going to try, it's kind of arbitrary. You kind of just pick numbers and see how they look. My red was really weak here. So, and this is also based on what I kind of know of my samples, but just pick random, like whatever number, you know, if 100 is way too low, then increase it by a lot. Increase your laser power. And there's a balance between time and laser power. And again, help will help give you more information. So now if you wanted to cut off some from the top and some from the bottom, you can say, okay, so I don't quite need as much. I can get away with this, and then I can cut this down, you know, whatever makes sense here. And then once you make those changes, oops, and an extra period here, let me just delete that. Okay, so you want to save it again. do you want this experiment to update with the new version on the rescan? And I want to say yes. So if you come over here, this rescan is now what we just did. Again, you're gonna add your assay layout from today, and then I again call this a test. And just to compare, I'm gonna do the same well. So if I click on this, for the pre-scan, it's gonna be 5x. It's gonna look at just this one well, this one box, and it's gonna do the first 500 microns. Oh, so one thing that is really important is, so I did this well, I just imaged it on the 20x water. So now there's gonna be water on the bottom of my plate. So I'm just gonna hit eject. I'm gonna wipe off the bottom of my plate to remove all the water, and then I'm gonna re-image. So now if I were to have focus issues with the 5x air, I would assume that it's got water on it from the bottom of my plate. So I'm just gonna do this again. I'm gonna call this test, and I'm gonna hit start. Now I can click on everything over here to see as it images. And again, because I'm switching from the last one I was imaging on was 20x, we're going back to the 5x air objective. So now it's gonna take a few more minutes for the machine to reorientate itself. Okay, so if I make this orange, it should start turning blue on my Z-stack as it images. So down here on the bottom, it's telling me that it's acquiring image alignment parameters is what it's doing. So now as you can see, it's detecting where my different steroids were. Now it's switching over to the 20x. And if you're sitting here, I don't know if you can hear it or not, but the machine's making some pretty funky sounds. Which isn't anything to worry about. It just sounds funny when it's doing this. So right now it's flat fill correction profile estimate is what it's doing. Okay, so now it started imaging on my 20x. So once I click on this, this is moving because I'm hitting up and down buttons on the keyboard, just so you know, since you can't see that. So again, you know, I can see that my background's pretty low. Even these numbers that aren't nuclei are significantly different than where my nuclei are. If I go up towards the top, I can see that the nuclei intensity still looks good. So now let's see if my cell tracker red look intensity is any better. So this is still pretty low. And the other thing to mention too is that the intensity matters. So this is an artificial view kind of, because it's on highlight. So like if you came here, the white, normally on a confocal, white shows that's overly expressed, but just because this is such a low intensity, and so I like looking at it on this view so I can see where my sample is. So I can see that it, you know, it should be here and it's pretty low, but when I compare it to my background, if I can try to increase the time of the laser power just to see if I can get these numbers up any. Because again, ideally I want them above 2000 all across. And this stain is kind of grainy, so it's hard to tell if you're like on the exact spot or not. And you can use your mouse to zoom in to see for sure. But yeah, this doesn't mean it's overly expressed. It just shows that this white area is a little, the intensity is higher. So again, right click to fit. So I can see that my intensity for my green is pretty high. And I go through my whole spheroid. So because I want my numbers to the whole thing to be above 3,000, I'm going to keep it where it is. It's not crazy high on the bottom. There's some spots that are higher, but I kind of want the whole, I'm going to detect this whole region when I'm going back to do my image analysis. So I kind of want this whole, you know, I want it to be a big enough difference all the way at the back end as well. So now you can see the whole two colors together, and then you can see my nuclei. And again, you can check another spheroid just to make sure that you're happy. You can check, you know, however many wells and spheroids that you're comfortable with. See, this one has, you know, some slight areas that are below. So I could bump it up a little bit, but down here it's a lot higher, so I think it's okay. And again, so the intensity down here is higher than as I get higher in my spheroid. Intensity is going to be lower, less. So I'm going to hit stop just because I don't feel like I need to look at more than these spheroids that were already imaged. So if you have any changes, then you do the same thing. You're going to go back to setup. Again, you're going to open your rescan. And then if I wanted to try to get my red channel a little bit higher, you know, I could bump this up some just to, so this is a catch-22, right? So if I increase this, this shows up here the max duration. So for one well, one thing, it's going to be 2 minutes. But if I increase this to, you know, roughly, this says 1 well, 13 fields, 45 planes, you see how this will go up significantly more. So you can kind of get an estimate of how long it's going to take versus if I have this at 1,000. So this changes it by 5 minutes. The other thing is that if you are noticing that there is background staining or crosstalk, you can change, you can say, keep these channels separated. So right now, cell tracker green and red are together. If you're noticing that there was crosstalk, you could have those imaging separately instead of at the same time. So once you make your changes, again, you're just gonna hit save. It's gonna ask you if you want to update the loaded rescan. You're gonna say yes. So here, if you can test it again to see if you're happy with the change in your red. I'm not going to keep going through it, but as you can see, this is a general idea of how you would go through the process of finding your spheroid in the 5X, having an analysis sequence to detect the middle slice, which will then determine where your 20X objective is going to image from. So here, you can call this, oops, it's 2020, not 2018. So this just stays with your experiment. So then you would hit, so then you have to go back. So if you're ready to go, you're gonna open your rescan. And now, because I have spheroids in all of these wells, I'm gonna select all of the wells. I'm gonna hit save. And again, this gives you kind of an estimate if you are going with roughly 13 fields, how long it's gonna take. So I think I was kind of aiming for closer to like 25. So for me, mine's gonna take a little bit longer. Right now, you can always image more versus less, but you have an idea of how long it's gonna take. And how many you select here doesn't matter, but do you want to proceed? No, because I forgot to save this. So I'm going to go here. I'm going to save my rescan. I'm just going to put it on my run. So now I want to save my pre-scan, and I want to do the same thing. Open my pre-scan, select my wells. I want it from the whole plate because I don't know exactly where my sample is. I'm going to select the whole well. I'm going to hit save. And we're just going to save that. Again, it's going to load into that pre-scan spot over here. So now my updated pre-scan, my rescan, again, attached to the assay layout. This shows you your pre-scan lens is 5X, your rescan lens is 20X. You select your name, and then you hit start. And this will start the experiment, and it will run for the amount of time. So once it finishes the pre-scan, it's gonna change the time. It's gonna have max duration here. This will update, and with how much time roughly it's gonna take your plate to image. I just want to show you real quick. So if you go to settings, data management, delete data. So I'm going to select my data. So mine is set up right now, but I just want to show you how this is organized, this kind of menu. So it's based on username. So I'm under my username. You always want to make sure you log into the software under your name. Okay, so then I labeled mine test. So this is plate name. If you want to change it to, it can be anything, like what objective or the and anything that you want, you can have it So I have image location is another one. So I have plate name here. So I organize mine by plate name, and what that does is that allows me to find my folder called test. And this is everything from today. So I'm just going to select all of that, and I'm going to go ahead and delete all of that because I don't need that any of that saved. It's going to delete everything that goes along with that. And you can check job status just to see where you are with that. But I'm going to be using the Opera Phoenix for a while, so I'll just let that run in the background. So that is how you, a general overview of how I set up my pre-scan, find my Z height, my spheroid and the 5x, and then I go back and it re-images on the 20x objective.